And I'm really excited for this one because let's just say Gary isn't exactly shy sharing his views. Not exactly shy. Gary Marcus will be joining us virtually from Vancouver, Canada. So we'll have him joining us up on the screen shortly. His keynote is titled ChatGPT, Godsend or Disaster. I love it. I love how binary it is. It's excellent. And he'll be taking questions afterwards. So please do submit any burning questions you've got via the online platform, and I'll ask them. And obviously, Gary pretty much knows everything, so you can ask him anything, I'd say. Now, Gary's a leading voice in artificial intelligence. He's a scientist, best-selling author, and serial entrepreneur, founder of Robust.AI and Geometric.AI, which was acquired by Uber. He's well known for his challenges to contemporary AI, anticipating many of the current limitations decades in advance. He's a bit of a psychic. And for his research in human language development and cognitive neuroscience. An Emeritus Professor of Psychology and Neuroscience at NYU, he's written 5 books, including The Algebraic Mind, Kluge, The Birth of the Mind, and the New York Times bestseller, Guitar Zero. He's often contributed to The New Yorker and Wired. His most recent book with Ernest Davis, Rebooting AI, is one of Forbes' 7 must-read books in AI. And without any further ado, please, let's all welcome Professor Gary Marcus.
Thank you very much. Can you all hear me?
We can all hear you, Gary. Can you hear me?
Excellent. I can hear you just fine. I don't have a title slide that matches what you promised, but you can ask me questions if my views are not clear enough in the Godsend department. I'm going to give today a little bit of an idiosyncratic first-person narrative on how I see the history of AI. Of course, I wasn't there at the very beginning, but I've been there for a lot of it. So here's a very brief history of AI. It's given a little bit tongue-in-cheek, but here's how it goes. In the beginning, there was hubris. Within a generation, the problem of artificial intelligence will be substantially solved, said Marvin Minsky in 1967 after the field had been running for about a decade. And all that hubris was good because it raised a ton of money. But not every promise was kept. By 2012, 35 years after Minsky's famous prediction, the problem of artificial intelligence most certainly had not been substantially solved. And then, so the legend goes, there were GPUs, graphics processing units, and the graphics processing units were good because they allowed, so the story goes, so the story goes, they allowed for a revolution. And I think everybody knows the revolution that I'm talking about, the deep learning revolution. And in November of 2012, John Markov wrote about that revolution in the front page of the New York Times. And part of what he said, I think, is true. And part of it, I think we should pay careful attention to the wording. He said, there's been a number of stunning new results with these new learning methods, quoting Jan LeCun, who later went on to be my nemesis and vice versa, I suppose. He said, the kind of jump that we're seeing in the accuracy of these systems is very rare indeed. And I think that's true. And then he went on to say, that these advances have led to widespread enthusiasm among researchers who design software to perform human activities like seeing, listening, and thinking. And I think all of that held up. And then I think the key word in the next sentence is the promise. He said, Markov said, they offer the promise of machines that converse with humans and perform tasks like driving cars and working in factories, raising the specter, of automated robots that could replace human workers. Well, I would say 11 years later, we still don't have machines that can drive cars. They still aren't replacing human workers all that much. And we still actually have a long way to go despite all the enthusiasm. But in any case, Markov wrote this in November 2012. And 2 days later, I replied in the New Yorker. And I think that also helped set a lot of what we've been seeing ever since. So I wrote a piece called, Is Deep Learning a Revolution in Artificial Intelligence? And I said, realistically, deep learning is only part of the larger challenge of building intelligent machines. Such techniques lack ways of representing causal relationships, such as between diseases and their symptoms, and are likely to face challenges in acquiring abstract ideas like sibling or identical to. I said they have no obvious ways of performing logical inferences And they're still a long way from integrating abstract knowledge, such as information about what objects are for and how they're used. And then I went on to say, to paraphrase an old parable, Hinton has built a better ladder, but a better ladder doesn't necessarily get you to the moon. And at that moment, in November of 2012, I would say that the basic tension of the next decade, continuing today, was established. Then a decade passed. In March 2022, I wrote an essay that really ruffled a lot of feathers. It was called Deep Learning is Hitting a Wall, March 10th, just over a year ago of 2022. And I said, even though people are very excited about deep learning, these systems are still particularly problematic when it comes to outliers that differ substantially from things that they're trained on. I gave an example of a Tesla maybe running into a jet or something like that. I said, for all its fluency, GPT-3 can neither integrate information from basic web searches nor reason about the most basic of everyday phenomena. I said that current deep learning systems frequently succumb to stupid errors. And I said that GPT-3 was prone to producing toxic language and promulgating misinformation. All of this made people really, really mad. And then DALL-E came along, and not only were they mad, but they gloated. They said, DALL-E is here. It can generate images from text. And Sam Altman, the CEO of OpenAI, said, AGI is going to be wild. And Nando de Freitas from DeepMind, the high-level executive there, said his opinion, AI is over. It's all about scale now. We'll just make these systems bigger. All this stuff that Marcus worried about, we don't need to worry about that anymore. And so people were riding really high in April of 2022. And in fact, skepticism of me became a meme. Not just skepticism, but ridicule. So people were skeptical about the skeptic. The best one, I think, was Yasha Box, a picture of a robot leaping over a wall, making fun of me. It was pretty funny. Even I laughed. Sam Altman said, give me the confidence of a mediocre deep learning skeptic, which I think was unnecessarily unkind and it doesn't hold up very well over time. Greg Altman drew with DALL-E, deep learning is hitting a wall, but if you read it carefully, it said deep lepning, which sort of seems like hitting a wall to me. Jan LeCun said, not only is AI not hitting a wall, the cars with AI-powered driving assistants aren't hitting walls or anything else either, which wasn't actually true, but sure seemed like a nice comeback to me. Later in that epochal year of 2022, even more progress was made. So jokes and sentience and compositionality were all said to have been solved at Google. But one must always look at the fine print as a scientist and say, can I look at the data? And so far, Google hasn't let us look at the data for any of these things. So buyer beware. The media, meanwhile, expressed considerable skepticism. The New York Times, enthusiasm. This is jet lag speaking, these speech errors. The media expressed considerable enthusiasm. Kevin Roos in the New York Times said, we need to talk about how good AI is getting. And he talked about the brilliance and weirdness of ChatGPT. There was a lot of enthusiasm in the media. And then suddenly and unexpectedly, even to me, there was a plot twist. By the end of 2022, the narrative actually began to change a little bit. The first thing that I noticed is that promises around driverless cars started being scaled back. There was a great article by Max Chafkin in Business Week where he noted that even after $100 billion had been investing, self-driving cars still seem to be going nowhere. Apple delayed its long-rumored self-driving car, and Elon Musk, or actually Tesla's lawyers, said that although self-driving technology might be a failure that hadn't materialized, it wasn't a fraud. Well, that's a really big walk back from, hey, we're going to deliver this next year, which is what Musk had said for the previous 10, or previous 7 anyway. The second thing that happened is people began to worry publicly about large language models. Some of this really began with Meta. Meta had a system called Galactica that they released in November of 2022, and it made up really fluent bullshit. For example, you could have it write a story about the benefits of eating crushed glass, and it would proceed to say that it had conducted studies and it was examining whether the benefits of crushed glass were coming from the phosphorus content or some other source. So it looked like very good science, and it was totally garbage. And a lot of people got upset. I wrote an essay called A Few Words About Bullshit, and a couple days later, the thing was taken down. I also expressed worry in the Scientific American that although these platforms were easy to use, they were also potentially dangerous, in part because they could create an avalanche of misinformation. And then, this is the thing that surprised me the most. the skeptics started to change their tune. So Jan LeCun started saying most of today's AI approaches will never lead to true intelligence, which was the whole point of the deep learning is hitting a wall essay. And then he seemed to borrow a page even more directly from my book. He said, you have to take a step back and say, okay, we built this ladder, but we want to go to the moon. There's no way the ladder is going to get us there. Meanwhile, Sam Altman, who had been so critical of me, in December of 2022 said ChatGPT is incredibly limited, but good enough at some things to create a misleading impression of greatness. It's a mistake, he said, to be relying on it for anything important now. It's a preview of progress. We need to have lots of work. We have lots of work to do, excuse me, on robustness and truthfulness. He's basically saying everything that I said in the deep learning is hitting a wall essay. So he went from ridiculing me to basically imitating me. Skip that. Thought I had another slide here. I guess I don't. So all of this raises a question. If deep learning is a better ladder and a better ladder doesn't necessarily get you to the moon, what should we do about it? Well, one suggestion I'd like to make is that it takes a village to raise an AI, and that this is not a solution, or sorry, a problem to be solved by one person alone. So what I've been doing for the last few years is trying to put on debates with Vince Boucher where we get a lot of different voices. In December of 2022, for example, we had everybody from Noam Chomsky to Jürgen Schmidhuber, Kai-Fu Lee, Francesca Rossi, Yejin Choi, Ben Goertzel, and so forth. It was really quite a spectacular cast. And we asked people 5 questions. We said, can we turn to the cognitive neurosciences for inspiration? How can we make progress in common sense reasoning? How should we structure and develop our AI systems? How can we build AI systems that reflect human values? And what should we do morally and legally to ensure a bright future? All of this is at agidebate.com. It was a 3.5-hour debate. Many people were in Europe and stayed up until the wee hours because they were so interested. I highly recommend it, and that will allow you to go beyond what I can say today. My own suggestion in that debate was that we should look towards human cognition. I don't think machines should slavishly replicate human cognition. Airplanes don't fly exactly like birds, but the Wright brothers learned something from birds. We might learn something from human cognition, and here are 4 suggestions. The first is that humans are really good at abstraction. We can learn things like how to sort something or how to count something, and we can do it indefinitely and infinitely. Whereas ChatGPT can kind of fake a lot of that stuff, can look really impressive, but often the details are wrong. So there's definitely a dream right now of having computer programs write code directly from human text. The reality is most of those systems only work some of the time, and we really need human debuggers, human coders to figure out what's wrong with them. Here's a great example of what we should get. Say, write 10 sentences about baseball. That's an American sport for those of you who know cricket. It's kind of the American version of that. Write 10 sentences about baseball and then print the sentences in sorted order from shortest to longest in terms of number of words in each sentence. In parentheses, after each sentence, state the number of words it contains. And the system seems to be off to a great start if you squint your eyes and don't look very carefully. It says baseball is a popular sport, 3 words. It's played with a bat and a ball, 6 words. Team at bat tries to score runs by hitting the ball, blah, blah, blah. The only thing is, if you actually count the number of words, it's wrong. Baseball is a popular sport is not 3 words. Similarly, when you say sorted from shortest to longest, it seems like it's off to a great start. It says 3 words, 6 words, 7, 10, it's counting up, 20. Then it's back down to 16 and 16 and 12 and 12 and then up to 25. Doesn't really understand what sorting means. Can get little bits and pieces of it by matching bits of text, but it doesn't really understand the abstraction of sorting. Second example is reasoning. So if I say, suppose a container holds 8 pennies, and if I start with 6 pennies, and then someone gives me 5 more, will they all fit inside of X? Any ordinary human adult or even child who's not 4 years old is able to solve this no problem. But these systems are very, we sometimes call them stochastic or random or just unpredictable on these things. Sometimes they get it right, sometimes they get it wrong. Francois Chollet had a nice way of putting it. He said, so far, All the evidence that large language models can perform few-shot reasoning on novel problems seems to boil down to LLMs store patterns they can reapply to new inputs, which is to say that it works for problems that follow a structure that the model has seen before, but doesn't work on new problems. A third thing that's incredibly salient to linguists and has been central to the study of linguistics for the last 100 years is that we understand compositionality. We understand that larger wholes are made of smaller parts. So if I say the sentence, a red basketball with flowers on it in front of a blue one with a similar pattern, you're not just looking for red things and basketballs and flowers. You have structure from the whole that defines what your expectation is. This system, this is Dolly, isn't able to do that reliably. It's getting lots of the bits and pieces, but not assembling them correctly into a whole. So, for example, in many of the images, the blue one doesn't have the same pattern as the red one, or the flowers are on the blue one but instead of the red one, and so forth and so on. In a more systematic study in October in Archive, Evelina Leveda, Elliot Murphy, and I looked at a whole bunch of things that you would find in an introduction to linguistics class. Things like negation and coordination, putting different sentences together. And these systems were basically a chance. They're amazing. They can grab something from every word there, but they still don't really understand how all those words fit together. And the fourth thing, and the one that I'm most concerned about in terms of its political implications for the world, social implications, is factuality. Large language models are about predicting words and sentences. I sometimes call them autocomplete on steroids. They're not fundamentally about facts. And this gets them into trouble. Here's an example. Galactica made up an essay that went like this. On March 18th of 2018, Tesla Inc. CEO Elon Musk was involved in a fatal motor vehicle collision in which he was a passenger in a Tesla. The driver of the other vehicle was unharmed. So it's telling us that he died. But we all know that Elon Musk didn't die. There's nothing in the training set that supports this. Some of the systems sometimes things that are untrue because they borrow them from Reddit or something like that. But this is not a case of that. It's not a case of the system simply mimicking something that's in the database. There's lots of things in the training set that go against it. Why does it do? The reason it does that is because really it's learning about relations between clusters of words. So the cluster of words on March 2018 could be followed by a lot of things. Tesla is one plausible one. The word Tesla could be followed by a lot of things. Inc. is one of them. Tesla Inc. could be followed by CEO. Tesla Inc. CEO could be followed by Elon Musk. And then it's abstracting in a certain sense from these categories. Abstraction is not quite the right word. It's clustering. But it's putting Elon Musk together with something like other white males from California who own Teslas. And there was another white male from California who died in a fatal Tesla accident in 2018, but it doesn't know which one's which. It's not actually keeping track of facts. Well, this is a serious problem because it means you can use these things to make up misinformation, or they can do that all by themselves. People have been talking a lot about chatbots for search. I don't even think I need this slide anymore. When I first wrote it, it wasn't widely recognized how bad these systems are, how intermittent they are. They work some of the time, but not all of the time. They frequently make weird and bizarre mistakes. Probably everybody in the room has experienced or read about that at this point. So we need to learn a lot from human cognition, I think. And here's an overall summary. I think the COVID should be a wake-up call for AI. It's motivation for us to stop building AI for ad tech and things like that, and to start making AI that can really make a difference. But to build deeper AI, the kind of AI that can, for example, read a medical literature, we need to do more than just learn the frequencies of words and sentences. If we want to build AI that can help us with medicine, that can help us address climate change, power robots to take on some of the risks that human healthcare workers were taking, and so forth, we need to do something different. We don't need to just fool people into thinking that a program is intelligent by predicting text. We need to build programs that actually are intelligent. So to get to a deeper AI that can operate in trustworthy ways, even in novel environments, we need to start working towards building systems with deep understanding and not just deep learning. And I thank you very much.
Gary Marcus, Professor Gary Marcus, everyone. Hi, Gary. Can you hear me?
I can hear you just fine.
How's it over there in Vancouver?
It's a lovely day here. It's no longer raining the way it was from recent months.
Oh,
It's
it's different.
gorgeous
It's
outside.
different to Scotland. Then it's always raining here. Thanks so much for that. Extraordinary, insightful, brilliant. Thanks so much. Got a few questions for you now, Gary. If you can stick around with us for a few minutes.
Please, please. I
Um,
finished early so you could ask.
brilliant. Okay. So, the first question is, which I'm not sure you necessarily addressed, is how fast are we moving right now? I mean, you've obviously been in this at the forefront of the AI industry for many years now, decades. Do you think something very interesting is happening right now? And by right now, I mean the last like 2, 3 months. How quickly are we moving?
For sure, something very interesting is happening. Um, there are some good things about it and some bad things about it. So, um, in my opinion, we're moving a little bit too fast. It's certainly seductive to play with these machines. I think to some people it feels like they have a new friend or something like that. Um, but we don't really understand the risks. There was a report yesterday by Europol over on your side of the Atlantic that pointed to a lot of problems. One was misinformation that I've pointed to a lot. Another was the ways in which bad actors could use these things for phishing people's credentials. Another way is which they could take the phishing for credentials and turn that around, for example, into helping terrorists do various things. There are a lot of potentially negative applications. The one that I worry about most is producing misinformation at scale and swaying elections, which I think could be devastating for democracy. So we have all of these negative cases on the one hand. And there are a lot of positive cases, but my sense is that people are moving really fast. Up until um, a few months ago, Google had technologies like what we're seeing now, and they thought they're too unstable, they're not reliable enough. Let's not release them till we fix them. And suddenly, there's immense pressure to release them, even though they are obviously problematic. And we get into this question about are the net benefits better than the net harms? We don't actually know the answer. The only intellectually honest answer is to say we don't quite know the trade-offs here. Maybe we should slow down until we have a little bit better handle on it. So yes, something is absolutely happening. Whether it's the right thing or the best thing, I don't think we have a handle on that yet.
Do we think that this is separate to how other technologies are rolled out across the tech sector? I mean, traditionally, as an industry, the tech companies are fast to release stuff without the proper testing or without knowing the implications, right? We'll just get it out the door.
Well, I mean, this is what the tech industry does, and I'm not sure that it's in the interest of society as a whole. I think that with social media things, we're kind of kicked out the door, and we had problems. We had influence on elections and depression and so forth. I hope we won't repeat the mistakes of the past. But then, even so, this is much faster than before, and the potential impact I think is even larger than it was with social media. In part because it interacts with social media, because of the tendency of misinformation, and in part because the sheer scale is even much faster than it was
Mm.
for social media. So 100 million people adopted ChatGPT in its first few weeks. We've never seen anything like that before, and it's just clear every day a new kind of negative use case is popping up. It's just clear that we don't have a good handle on it relative to the speed at which it's being pushed out.
How worried are you, and should we be worried?
In general, I didn't know if you're going to finish the
Nope.
sentence. Yeah, how worried am I? I'm pretty worried.
Well, I mean, you
Um,
you personally,
I,
Gary, because obviously you're an expert here, and you can kind of the way I look at things when I'm trying to gauge my concerns in life is basically to compare it to what's happened over history and over time. So, where are you at right now?
I'm pretty worried, and the fears come from a kind of confluence, like a perfect storm of factors. One is the speed at which this stuff has been released. Another is the kind of instability of it, the unreliability of these systems. For example, Bard was just released, and there was a paragraph about my book Rebooting AI, and 3 sentences had 5 errors, and that's kind of disconcerting, the unreliability of it. And then the third thing that's or disconcerting rather is the degree to which the big tech companies seem to have abandoned the principles that they had talked about. I noticed words behind
Mm.
trustworthy, ethical, inclusive, and so forth. Those words were repeated by these companies, and suddenly they seem to be of less interest. So you have the scale of it, the kind of unknown periphery of how many weird use cases there are, and potentially dangerous use cases, and the fact that the leadership that we did think we were getting from the corporates just suddenly it doesn't seem to be there anymore. There's going to be a big announcement tomorrow. I won't quite give it away, but it's already been leaked a bit. There are a bunch of us that are concerned and are going to speak up.
Thanks, Gary. Now, there's a few questions that have come in from the audience, so I'm just going to ask you those. Um, One's come in that says, in this era of AI aided writing and research, in this era of AI aided writing and research, there's a big concern for some people and academics around the issue of copyright and plagiarism. What are the things being considered to address these concerns?
I think they're difficult. So um, on the copyright issue, it remains to be seen whether existing laws can really protect, for example, artists and so forth. Um, we may need new laws. I think society has to decide what we think is adequate compensation for an artist whose work is swallowed up by these systems. There's some technical questions there about the degree to which they are copying things that exist, to degree to which they're really going beyond what's there. And there are social questions. We have to decide what we think is fair. On the plagiarism issue, I mean, it's kind of similar. These systems are very good on the written side at kind of substituting with synonyms things that are already there. They're not as good at being genuinely original. It's already, extremely attractive to students to use these things. And I don't think that we can actually stop that. If I were a professor, what I would do is to say, go ahead, use ChatGPT or one of these systems, and then write an essay about what it gets wrong. Try to learn about the strengths and weaknesses of these systems. Try to explain how you would write something more interesting, because most of what they write is not very interesting. What would be your own unique angle on something? And so I would try to turn all of this into a teachable moment as best I could.
Thanks, Gary. Now, you're in Vancouver. We're in Scotland here in Glasgow. What do you think about Scotland on the global AI stage? Do you think we're there? Do you think we've got the potential? What do you think about us as a nation when it comes to AI?
I mean, I'm not sure I'm completely knowledgeable there. There's long been a very strong
It came in.
tradition in Edinburgh and Glasgow in the cognitive sciences that I think is very relevant to AI research. Um, I think I know Edinburgh a little bit better, but for years there's been really good connections there between people working on AI and working on the human mind, and I think that's important. And I think that's one of the things that you guys can try to leverage to become an important player. And if I could take a half a step back, most of the field right now thinks that large language models are the answer to AI. My own view is that they're kind of a detour. In fact, Jan LeCun, who historically was my nemesis, has been lately saying that these things are large language models are kind of off ramp in the journey to AI. So the question is, what do you need? And what I'm arguing is you need a firm basis in human cognition to solve a lot of problems that haven't actually been solved yet. And I think, that's a good place for Scotland to get into the mix.
Thanks so much. Another question from the audience here is so they loved your breakdown of the aspects of human cognition current AI can't mimic. So, to what extent do you believe cognition needs to be embodied, either as a humanoid or a different type of physical body, to gain these capabilities?
I don't know if it's absolutely required, but I think it's certainly
Oh,
helpful. If you look at human children, there are some that grow up with disabilities, so they can't really move around the world, and they still learn a lot. Um, on the other hand, human children, once they can move around, start learning things really fast. Um, my guess is that when we can make something of embodied cognition for robots, that it will be really helpful, but that we're starting with systems that are blank slates that don't really know how to assimilate the experience that they're having, so they don't make much of it. But eventually, I think we'll be able to do better with that.
sure. Thanks, Gary. Another question that's in here. Can you explain how ChatGPT is lying, or is it a misnomer? Isn't it just reporting? Isn't it just? Let me start again with that question. Can you explain how is ChatGPT lying, or is it a misnomer? It's just reporting false information, right? Isn't it?
It's not literally lying. It has no intent. All it is predicting next words and sentences. But there are two ways in which it can go astray. So one is it can report something in the database that isn't true. So for example, in the database are probably a bunch of sentences about COVID involving microchips. Sorry, COVID vaccines having microchips in them. So the system reads that from Reddit and it repeats it. It's nonsense. And a really smart system wouldn't repeat that nonsense. It would actually consider, is this plausible? Could you stick a microchip in there? Would people go to that expense? Is there any evidence for this? The current systems are just mimics. They're not actually reasoning about it. So that's one problem, is they can mimic things that are untrue without validating them. And then the Elon Musk car crash example that I gave is an instance where the system, because it doesn't actually understand the properties of the world and is just predicting words that kind of sound good together, can come up with stuff that just isn't true at all. It's not deliberately lying. It's not with intention, but it means that we can't trust these systems. To give one more example, Bard, made up a subtitle for my book that might have made sense. It said that my book, which was in 2019, talked about large language models, which weren't really popular then and we didn't talk about. And it just put stuff together that like books of this sort are affiliated with words of that sort without thinking about like the timing, without actually looking to see what's in the book and so forth. So the complete lack of fact checking winds up with a lot of things that aren't true, even though it's not done with malice per se.
Sure. Gary, now you've been very critical of chatbots regarding how they don't really understand the context of language and don't really, I guess, have a full understanding of anything. But given how rapidly things are moving in the AI space right now, do you think your opinion may change soon, or maybe sooner than you think?
Well, it's possible, but I'll tell you this. In 2001, I wrote a book about, in part, why these things would hallucinate. And I've been right for 22 years since. In 2016, I wrote an essay about why driverless cars weren't going to work anytime soon. I've been correct about that. In December of 2022, I wrote 7 predictions about GPT-4, and all 7 of them were correct. I don't know that anybody else did better than that or even close. So, I have to look at my own track record, among other things, and then I have to look at how much the mechanisms have changed. And so I'm going to stand where I am for the moment. But I look every day. I see, did something new come out? Does it change something fundamental? And, I'm a scientist, so show me the data.
Professor Gary Marcus, thank you so much for joining us here at the AI Summit.
Thanks. My pleasure. And sorry I couldn't be there in person. Bye-bye.